Hey guys, how we doing? Sorry, I'm just trying to set up like multiple things here, which is stupid of me. I don't know why I'm doing that. Why do I want to do that? Hey Navid, media schema allow access. Yep, that's all good. We're doing level 3 today, right? Just wanted to double check. What am I doing? Am I lagging? How badly? Now I'm just testing, trying to stream at multiple, same as in, am I lagging, Emma, for you, or not lagging? Oh yeah, that part I know, because I don't know why it keeps happening, because I think it's like something to do with the distance between my mic, and I'm always messing around with that. Tomorrow, Harrison. Yeah, I can never figure it out. Actually, wait, let me just try something. I'm just going to try something. Give me a second. Main recording. Anywhere else? All right, so let's... Okay, I know you guys can hear me now, so that's good. Oh, wrong camera. Remove. C920. Okay. Oh man. Technical difficulties. The worst. Am I lagging now? Okay. Is my sound actually working? That's the question. Cool. I think I need to rejig a whole system here, but that's all right. That can wait later. All right, people. So what are we going to do now? We're going to be doing some calc questions. Yep. Hang on. Just need to copy this. Copy as a source, main recording. Paste as a links. No, whoa. There we go. Done. Finding the area between multiple curves. All right, now we're going to be doing some merit questions, guys. So, hey, Swant, how you doing? Gonna sort this out later. Let me just find some questions, and then I'll grab the questions, and then we'll actually get going. All right, so we'll start off with a couple of merit questions, and then after that we will jump on to some excellence questions. Did you guys want to do an old paper instead, like from like 2013 or something like that? Or do we want to do like a little bit of a little bit more tougher questions? Because I always feel like the tough questions are a bit crazy, but let's do some complex numbers first. Now, Harrison, I'm just doing level 1 because I'm going to do Wednesday, back-to-back Wednesday, Thursday. I think I did have that in the schedule, and then somehow I must have missed it. This can go here, and then... Where are we at? Yeah, So I did have it kind of all over the place, but I think with Tuesday today we're doing merit questions, and then level 1 maths reasoning as we'll do Wednesday, Thursday back to back. Cool. So you guys didn't tell me 2013 paper. Should we try questions from there, or do we want a harder one? Let me know. No, not really, Aurora. Just okay, harder. Okay, Liam. Let's do. Where did I put the integration questions? Sorry, just gonna load up. We'll definitely do excellence at 9 o'clock, Mary. All right, give me 1 second. I just gotta load up the questions. Where are we looking at? Let's go. Jupiter. Just give me a second, folks. Just opening it up. Sorry, I'm a little bit disorganized today. Calc 3. Oh, this is interesting. When did this come from? No, I didn't have that. Externals. Complex numbers. Let's go 2013. Let's go 2013. Go here, level 3 maths. 579. 577. Here we go. I've got it. 577. Oh man. 577. 577. Sorry guys, just give me 1 second. Got it, here we go. Alright, so these are the questions that are popping up. We're doing complex numbers. I think we did those ones. Should we do a couple of these root questions here? Fit. What about something like this? Let's start off with this, eh? That's a good question to start with. Complex roots question. Come on. Yeah, we'll do a couple of merit questions next, and then we'll jump on to the excellence one, all right? Cool. So this should pop up very shortly. Come on, man. How long do you need to take to sync? So we're going to do question C, folks. That's the one we're going to be doing at the moment. Samia, we're going to start off with complex numbers. We'll do a couple of complex numbers merits, then we'll jump to differentiation and integration, and we'll go there. Krish, they're not really, like, to be honest, they don't really fuss too much about that. Like, I think you'll be pretty safe with 2 decimal places. It's not like the other papers where they go a bit crazy with it. Just not having fun today with my tablet. Well, it is getting to about 4 years old now, so it is on its last legs. Come on, man. Like, how long did it take to sync? All right, we're in business. Mirhan, I think, if I remember correctly, people that said that they watched the complex numbers playlist, the I think, what did they say? They basically mentioned that if you can get up to the 15-hour playlist and do a few of those, I think you can actually get it. So I'd say go for it. Why not? 8 squared plus 8 squared, 16. All right, so let's actually do this question, because I've actually forgotten how to do all of this completely. I'm going to need a refresher because I haven't done complex roots in such a long time. All right, so we're going to do this first question here, and then after that I will pick up another merit question, which looks like this one here. I might as well just get the next merit question ready. Okay, so here's how we do this complex, this particular question. All right, so the first thing you want to be doing is you want to convert this into a polar form. I think my memory is coming back now. So the best way to do this question is that what I do is I actually just draw like a rough sketch of this straight away. So if you look at this, we've got 8 root 3 and 8 mi, 8 3 root 3 m as well. So if you look at this complex number, this complex number is going to be here because it actually says m is a positive real number. And if I look at it along the x-axis, this distance here is going to be 8 root 3 m, and then the height of this triangle is actually going to be 8. Now I'm not going to 8m. What I'm going to do is I'm going to first work out the modulus itself. Because once I've worked out the modulus, then I could actually work out the angle, and then once I do that, then I just add 90 to each of them. You're pretty much good to go, right? So at the moment, what I'm going to do is I'm going to work out the modulus. Now the modulus is basically the real squared plus the imaginary squared. So what I'm going to get is 8 root 3 m squared plus 8 m squared. So when I look at inside the bracket, I've got 8 squared, which is 64. So 64 times 9 m squared plus 60, that shouldn't be 9, that should be 3, sorry, plus 64 m squared. So what I'm going to end up with is, in the calculator, I'm just going to work it out, guys, because it's been a bit of a long day. So 64 times 3, that's 192, plus another 64 equals 256. So what I'm getting is 256 m squared. Then I'm going to take square root of 256. That's equal to 16. So this modulus becomes 16m. Now the next thing is I got to work out the argument for this. The argument is the angle, that is this part here. Now we've got m, we've got 8 root 3. So what we're going to do is we're going to separate this out. So we're going to just take this triangle, but we're going to kind of look at it as divide everything by 8m. So if I divide everything by 8m, this is going to be 1, and this is going to be root 3. And this is really important, because what happens is that when you see 1 and root 3, you should remember your level 3 formula sheet. So if you go to your level 3 formula sheet, we've got third and a 1, and you can see that there is a special triangle that has a third and a 1. Now this is pi over 6, so that's 180 divided by 6. And then you've got pi over 3, which is 180 divided by 3. So we're looking at this tiny little angle here, which is going to be 30 degrees. So once we have that as 30 degrees, we are pretty much good to go, because we actually have our, what do you call it, to the 30 degrees. So we can actually say that Z4 is equal to 16m cis, and I like to work in degrees because it's easier to manipulate. So that's going to be 30 degrees, which means Z1 is going to be 16m cis 30 to the power of a quarter. So your first Z root is going to be 16 to the power of quarter, m to the power of a quarter, cis 30 times a quarter. When we do this, we're going to get Z1 is equal to 2 m to the power of a quarter, cis 7.5 degrees. I don't know why I'm going percentage. Now, because there's actually 4 roots here, we're just going to add 90 to all of the angles. So Z2, Z3, Z4, they're all going to have the same modulus, which is 2m quarter, 2m quarter, 2m quarter, and they're all going to have cis. Then you're going to get 97.5, 187.5, 277.5, and we are done for this question. Conversion of radians to degrees. I always like to do this because it's like pi is equal to 180 degrees. So if you say pi radians, then if you want to convert it, I just divide it by pi. Yeah, I always, in my head I can do it, but I think it's you multiply it by, what is it, degrees to radians, you multiply it by pi over 180. Radians to degrees, you do radians, whatever radians is, 2 times 180 over pi. Yeah. So yeah, this is a merit question, like a complex roots question is a merit question, and Boo Boo Gaming, unfortunately this is from Kohia, massive thanks to them for providing me with the paper, but unfortunately it's not something that that I can just share out, because it was I was kind of given I am going to make exam papers for it, but yeah, just won't be able to do it this year. Yeah, I know. There's nothing wrong with working with radians. I prefer working in this particular question with degrees, because it is just so much more easier to manipulate. Questions, guys? Any questions with this? Otherwise, we can move on to the next one. I'm scared to touch my phone because it's like there's so many notifications. It's ridiculous. No questions? Yeah, I think this particular paper, we already did the excellence questions in the excellence streams, Boo Boo Gaming. So at 9 o'clock every day for the last 2 weeks, we've been doing excellence questions. So they are all excellence questions, and I don't think those are the standard NZQA ones. Yes, next font, you can definitely do that. So if you have 8 plus 8i, you would just find the modulus, which is square root of 128, cis 45 degrees, and you're done. That's your first, let's write it in polar form right there. Yeah, as I said, Poo Poo Gaming, we've done the excellence questions in the live streams before. All right, chuck us a quick, easy merit 1. And while you guys are doing this, I'll just find another one. Daniel, to be honest, like I had a variety of range of mixed reviews. You know, look, I'm gonna be brutally honest with these exams. Like, if you prep for like a week for a level 2 exam, you're gonna find it hard because you're just not. The whole point is, like, you know, you got to be exposed to these types of questions. And the more you do it, the more you kind of realize, oh yeah, this is how I use it. Because most guys think that exam questions are like, oh yeah, this is just the same question they ask and ask. It's not. You're meant to think differently for these questions. And I would say, like, you know, predominantly you need about 1 to 2 months prep work leading up to it before you go, yep, I'm actually confident with this exam. And the guys that came out confident are people that, like, you know, I see the regular names that pop up on my channel, on the, you know, they're attending tutorials and asking questions. So yeah, I wouldn't, like, you know, the question that I did earlier today with the quadratic, that was a really lovely question, because I'm like, that's a really nice question, because they've actually hit the target market correctly. There's nothing hard about it. It's just the more questions you do, the more practice you get, and then you kind of just nail those questions. But yeah, some were complaining about, a lot of them said calculus was real easy. Yeah, the question, I think I wrote it wrong though. It should have been x plus 1 in the numerator and x minus 1 in the denominator. All right, how are we going with this one, folks? Are we ready for me to go through the answer yet? Do I have time to go get a cup of coffee? Jacob, this is from Kohia 2013 paper. Plus or minus square root of 3. All right. Okay. I think, yeah, we're good to go. Let's give it a go with this question. Now, look, find the value of k for the quotient, blah, 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 if p is a real number. So all you know is p is a real number. So what we're going to do is we're just going to have to rationalize the denominator. So that means we got to multiply by k minus I and k minus I. When we do this, we're going to get a nice little kind of like a quadratic setup here. So we're going to go FOIL, and same thing for the denominator. So we're going to get 3k minus 3i plus k squared I. What else do I get? Minus ki squared divided by k squared minus I squared. In the numerator, I get 3k minus 3i plus k squared I, and this becomes plus k because I squared is equal to -1, and -1 times -k is plus k. In the denominator, I got k squared plus 1 because I squared is -1 again. So now I collect the real values. I've got 3k plus k plus k squared I minus 3i, and this is k squared plus 1. Now, it is telling you that p is a real number. So p is real number. That means p has 0 imaginary numbers. So because of that, what we can say is that the k squared minus 3 should equal to 0, because that's the imaginary part. So k squared minus 3 is equal to 0, k squared is equal to 3, and then k is equal to plus or minus 3. This is the merit one that we're doing, J. Crow. Yeah, this is nice and simple little merit. All right, we'll do one more from here with a merit question, and then I'll go grab me a cup of coffee. By the way, let me know if it's... Oh, yeah, sorry. Square root of... There we go. My bad. Nah, it should be square root of 3. My bad. Just rushed the question through. Yeah, I had a crazy day today because I had to go to A&E with my kid and came back. I saw the exams and I was like, oh my god, there's so much work to do. Ready for next question? Are we happy with this? All right, next one then. Yeah, 3 merits is a good idea. Let's go to, after this one, I'll do the differentiation one, all right? Differentiation. Copy. 578. Where are you? 578. 578. Copy. I need a paper doc. Wow, this is a merit question? That is brutal. Okay, got a couple of merit questions there. Will you do integration today? What is the theme today? I think we're doing complex numbers excellence after this. Sorry, just 3C. Question 3C. Nice. Horrible enough, this question. 3C. Boyga, it was, the option for me was KFC, and trust me, I almost became the assistant manager at KFC. It's gonna get a bit crazy, isn't it? There's the fireworks going off for you guys in the background as well. Yeah, this, unfortunately, today is gonna go crazy near my area. It's nuts. Like I'm looking outside and it's just like pop, pop, pop everywhere. We'll see how we go. If it gets a bit more crazy, I might just have to call it because I'm getting a headache from the fireworks. I usually put my noise cancelling headphones on and just go to sleep. All right, how are we going with this question, folks? Are we ready for me to go through the answer? Cool. So this question here, what we've got is, it's a bit awkward, this question. I mean, how would you do this? My suggestion is, well, okay, that's good to know. What do you say? Anterix. That's such a unique name, Anterix. I hope I said that right. Sorry, the fireworks are gonna go crazy soon. I think I might do like 2 more questions and call it for the night, guys, because tonight is just gonna be super crazy. Welcome to South Auckland. All right, so what I'm gonna do is I'm actually gonna convert this square root of 2 cis 7 pi over 4 into a far right. I can't concentrate, into polar form. And I mean, I could do this the long way, but I think there is a shortcut here. Where is it? Calculus? No, it's not in calculus. Complex. I think it's this. I'm gonna try it just to see if it works, because I can't remember if it works or not. Only thing is, I don't know how I did the cis format. Do we remember how to do this? Does it go... Seven pi over 4. Syntax error. Where? Oh, there's that argument button. Where is that argument button? That didn't work. Oh, it's because of my degree. No, that didn't work as well. Is that the one there, or is it? I think I've stuffed up the argument button. Where's the shift setup complex code? Shift setup. Your mode is in complex. I've seen the... stupid Subash. Just let it go. I'm going to do it the long way. Square root of 2 cos 7 pi over 4. Shift and X theta t button. Shift button under alpha. Oh, yeah, I see it. Okay. Sorry. Thank you for that. That's going to save me a bit of time because I don't want to do this. There we go. Nice. Okay, that just saves me a hell of a lot of time. So this is equal to 1 minus I. So then I've got A plus 2i. 3 plus bi is equal to 1 minus I. Then all I've got to do is just cross multiply, because A plus 2i equals 1 minus I times 3 plus bi. So I'm going to get A plus 2i equals 3 plus bi minus 3i minus bi squared. A plus 2i equals 3 plus b plus bi minus 3i. So A plus 2i equals to 3 plus b minus 3i. So from here, I can see the real parts is a equals to 3 plus b. The imaginary parts, 2 equals to b minus 3. Therefore, b is equal to 5. A is equal to 3 plus 5, which equals to 8. Pretty straightforward, isn't it? Questions? Any questions? Oh man. I don't know how you guys are coping. I want to hear the sound feedback on this. Hang on, let me just. Sorry, I was just checking the noise level for you guys. Sorry, I was just checking the noise. Oh, that's me replaying myself. Can I show you how to do it in the calculator? Yeah, I think all I did in the calculator was I basically just went square root of 2. So if I want to do like 2 cis and the angle, so I just did square root of 2 like that, and the cis is this little angle thing right here above x, so that shift that, and then I'm going to go 7 pi over 4, and then I click on option, go to complex, click on F6, and go to a plus bi, which actually converts it to rectangular form. Yeah, see, like if you were to rationalize the denominator, J-Crow, I think you're going to complicate it quite a bit because you will have A and B together, which means your simultaneous equations is going to look kind of awkward. All right, folks, I'm really sorry. Honestly, I can't put 2 and 2 together because it is so loud here. I might just have to call it a bit early because my head is like pounding with these fireworks. I will be back tomorrow, and I'm hoping that the fireworks is not too bad because, yeah, my head is like really killing me at the moment, and I apologize. Yeah, it's all right, Assault. I think like, look, they'll always change the schedule around, and hopefully they kind of do the business where they kind of adjust things for you guys. But yeah, as for the level 3, sorry folks, like it's, yeah, the fireworks, I can't concentrate at all because it's just like going all over the place. I will catch you guys tomorrow, all right? Because I'm actually gonna go get some shut eye because I need to put my headphones on. But I'll tell you what, I think just hang out in the chat, because I'm gonna stop the stream, and I'm just gonna post something on the chat for you guys to have a look at. All right, catch you later, folks.